Welcome to the Explainer. Okay, wow, let's just dive right in. Because we need to unpack the massive and frankly surprise launch of Valve's hybrid PC console, the Steam Machine. We're going to figure out exactly what this means for your game development pipelines. Listen, if you build games, engines, or tools for the PC gaming ecosystem, the entire landscape just shifted under our feet. Valve didn't just drop a shiny new piece of hardware today. They shipped a foundational update to SteamOS that completely redefines how Linux handles memory, power states, and performance budgets.
To get you up to speed as efficiently as possible, here's our agenda. Number 1, the Steam Machine arrives. Number 2, under-the-hood specs. 3, SteamOS, the software backbone. 4, why developers should care. And 5, preparing your workflow.
Starting right off with Section 1, the Steam Machine arrives. Let's break down this highly anticipated launch.
So let's talk about the price. At $1,049 for the base 512GB model, the pricing really reflects the harsh realities of current global manufacturing. As Valve pointed out, they initially modeled this pricing way back in 2023, assuming standard depreciation of tech components. But, well, reality had other plans. Instead, the industry experienced massive Gen I-induced RAM and storage shortages. The cost of memory absolutely skyrocketed. So this price tag directly reflects the reality of trying to secure those parts over the last 6 months in an intensely AI-hungry market.
Now, for the rollout itself, Valve implemented a randomized reservation queue running through June 25th. This is an approach specifically designed to thwart scalper bots and, let's be real, save your F5 key from total destruction. Instead of a stressful, server-crashing race at a specific minute, you simply sign up over a few days. Then Valve runs a one-time randomization to assign queue spots. It's just a much smoother pipeline. It gives them the time to filter out duplicate entries and make sure actual gamers and developers get their hands on the hardware first.
Moving right along to Section 2, Under the Hood, Specs. A look at the new hardware baseline.
The sheer power they managed to pack into this roughly 6-inch cube is honestly wild. We're talking a semi-custom AMD Zen 4 processor with 6 cores and 12 threads, paired with a massive RDNA 3 GPU boasting 28 compute units. And the memory setup is split brilliantly. You've got 16 gigabytes of DDR5 for the system, plus 8 gigabytes of dedicated GDDR6 VRAM. To put that into perspective, this setup delivers over 6 times the horsepower of the Steam Deck. It's targeting 4K gaming at 60 frames per second using AMD's FSR upscaling. Oh, and the whole shebang is entirely self-contained, featuring Wi-Fi 6E, Bluetooth 5.3, and an integrated power supply. No giant power brick required.
But here is where you really need to shift your perspective. If you are an engine developer, you can no longer treat this thing like a generic PC. Actually, scratch that. It's more like a highly calibrated appliance with strict thermal envelopes and power limits tuned specifically for SteamOS. Valve is shipping a tightly integrated Linux environment here. The days of relying on standard x86 desktop power profiles with, infinite thermal headroom, those are over. You have to optimize for this specific device. It runs whisper quiet specifically because the software and hardware are married together so perfectly.
All right, Section 3, SteamOS, the software backbone. The rising tide that lifts all Valve hardware.
This accompanying patch isn't just a basic driver update. It brings an incredible quality of life stack. We're seeing support for external HDR and variable refresh rate displays, alongside way better scaling for desktop mode on TVs, which is absolutely perfect for the Steam Deck's living room environment. But critically, for you testers out there, the Steam Deck LCD receives preliminary support for hibernation. This is huge. It means you can now test power state transitions and verify that your game state serialization actually survives a system suspend without relying on full cold boot shutdowns. Oh, and a fun little bonus for Steam Deck OLED users, you finally get a green charging light indicator when you hit your custom charge limit.
So arguably the most crucial point here is the discrete GPU memory management. This update directly targets the absolute villains of PC gaming, stuttering and frame pacing issues caused by shader compilation and texture streaming spikes. Previous iterations of SteamOS sometimes struggled with VRAM allocation under heavy loads on discrete GPUs. But by optimizing how the Linux kernel and Mesa drivers manage these memory pools, Valve is ensuring far more predictable behavior, which should virtually eliminate those super frustrating microstutters.
Which leads us to Section 4, why developers should care. What this means for engine optimization.
Because Valve is shipping this tightly integrated Linux environment rather than just a loose collection of generic parts, right now is a fantastic time to reevaluate your CPU and GPU scaling assumptions. Just a quick pro tip, if your engine or middleware just inherently assumes desktop-class thermal headroom, you might suddenly hit some invisible walls on the Steam machine. You really want to respect the appliance-like nature of this co-design to get the absolute best performance out of that Zen 4 and RDNA 3 architecture.
Finally, Section 5, Preparing Your Workflow. Let's get into the concrete action plan.
Dudarik.com put together a really great, concrete 5-step playbook for this. Step 1 is pretty obvious: update your test environment to the latest SteamOS. Step 2 is where it gets interesting. Test those hibernation workflows. Verify your saved data survives the transition without getting corrupted. For Step 3, you'll want to run your application with Vulkan diagnostics to really profile that VRAM allocation. Moving to Step 4, make sure you audit your custom input profiles, because Valve is also rolling out the new Steam controller ahead of schedule, which might shift your default bindings. And finally, Step 5, monitor your thermal limits. Benchmark your CPU and GPU scaling under sustained loads so you can map out those strict thermal curves.
This all ties back to Valve's core philosophy. Valve fundamentally rejects the closed-box approach. They're building the Steam Machine as an extension of the open PC gaming space, where you play the games you want on the hardware you want. They've explicitly stated they are not following the traditional console model of taking a massive loss on hardware just to lock you into a walled garden subscription service. The open nature of PC gaming is what drives innovation, and they are bringing that exact ethos straight to the living room.
So what does this all mean for the future? As the lines between desktop PC and living room console continue to blur, one really has to wonder, is this calibrated, open appliance the final nail in the coffin for closed gaming ecosystems? I mean, the Steam Machine offers the frictionless experience of a console with the boundless freedom of a PC. Will developers leverage these new SteamOS tools to make the experience seamless enough to win over the masses? That's the billion-dollar question we'll see answered in the coming months. Keep optimizing, and thanks for joining me for this explainer.